Hey guys, today we are taking a look at our notes for 8.2, which is all about arithmetic sequences and series. Now we took a look in 8.1 at just in general what a sequence is and what a series is, just their basic definitions, and went through some different problems with them. With today and tomorrow with 8.2 and 8.3, we're diving a little bit more specifically into types of sequences and series. So we're looking at how they grow and then getting a little bit better at how we can write their equations and how we can find their sums. So today we're looking at arithmetic sequences. And if you remember, an arithmetic sequence is basically a linear function, a linear equation, but turned into a sequence. We have a constant addition or subtraction happening from one term to the next in my sequence. So this is the formula that we will use. So in here, a sub n is your term, d is my common difference, n is the term or position number, and then a sub 0 is the term before the list starts. So my common difference, that's my pattern. That's how I get from one to the next in my sequence. And then a sub 0 is going to be that list, that number before the list starts. It's kind of my generator, I think is what I've called it in the past. So it's the number that would have to come before the first term in order to apply that common difference to get my first term. And those are the two things that we're looking for when we're writing our equation, because a sub n is like my y value, n is like my x value, this common difference d, and this a sub 0, those are the two numbers that I'm substituting in my actual equation when I'm writing my rule, which d is basically your slope, a sub 0 is basically your y-intercept. If you want to relate it back to y equals mx plus b form, it's very, very similar. It's just listed out as a sequence instead of, input-output list. So when we're trying to write our equation, because that's what we're asked to do here, we're trying to write the rule, we first have to identify what's my pattern. How do I get from one to the next? Which in this case, from -9 up to -2, we're adding 7. From -2 up to 5, we're also adding 7. We can see it's consistent, adding 7 each step of the way. So we know that my d, my common difference, is positive 7, because we're adding 7. So what my a sub 0 would be, whatever number would have to come before -9 that still fits in my pattern is a sub 0. So this term right here is a sub 0. So there's a couple of different ways of doing it. You could just logically look at it and figure out what you would have to add 7 to get -9. You could work backwards if we know that we're adding 7 to go that way. If we're going backwards this way, we would just subtract 7, right? Do the opposite of your common difference. Either way we slice it, we should figure out that a sub 0 has to be -16, because -16 plus 7 is -9, or -9 minus 7 is -16, but that's our a sub 0 term. So writing out our equation, our rule should be a sub n equals 7n minus 16. 7n minus 16, and that's our equation for number 1. Okay. Let's take a look over at box 2. We got some more examples here for writing our rule for the nth term. So here for number 2, we've got 3 to 8, so that's adding 5. 8 to 13 is adding 5. 13 to 18 is adding 5. So we can see that our common difference, d, is 5. Again, if we had to work backwards a term, that a sub 0 would have to be 5 less than 3. So that tells me that a sub 0 would have to be -2, because -2 plus that 5 would give me 3. So that means our equation, our answer, should be a sub n equals 5n minus 2. All right, one more. Now, in number 3, we're going from 55 down to 47, so we're subtracting 8 from 47 down to 39, which is minus 8. 39 down to 31, which again is minus 8. So our common difference is now negative. In this case, negative 8, because we're decreasing, we're subtracting. Which means when we go backwards, this number that comes before 55 has to be 8 bigger than 55 instead of smaller than, because now each step of the way we're subtracting 8. So in this case, my a sub 0 would have to be 63, because 63 minus 8 gives me 55. So that means my equation would be a sub n equals negative 8n plus 63. Plus 63. And that's writing my rule from my sequence. Okay. Over here in box 3, now a little bit different. Box 3 is telling us that we've got an example of a particular term. So this statement right here, a sub 19 equals negative 45, is basically telling us that the 19th number in my sequence is negative 45. And they're also telling us that my common difference is negative 3. So my list is decreasing 3 every time. The 19th term is negative 45. They want us to write the rule for the sequence given those two pieces of information. Now, there's more than one way of doing this. If you really wanted to, you could start with, I'm not suggesting this, you could start with negative 45. You know that's the 19th term. You could work backwards, and if you know you're subtracting 3 every time to get forward in your sequence, going backwards in your sequence, you would have to add 3. Negative 39 would be the 17th, and you can kind of work your way all the way back till you're at the beginning to be able to figure out that a sub 0 value. Because that's really what we're trying to do here. If we know our equation should be a sub n equals dn plus a sub 0, we know we're trying to find d and a sub 0. We already have our common difference d. All we're looking for is a sub 0 to write our equation. So instead of doing that, instead of making it overcomplicated and trying to work backwards 19 different terms in my sequence, what we can utilize is this other piece of information here. We know our common difference is negative 3, so we can put that into my equation for d. In my given point here, anytime I'm dealing with a term that I'm given, a sub 19 equaling negative 45, that tells us that the 19th term is negative 45. We've established that. Which means when n is 19, your a sub n equals negative 45. So what I can do here, my negative 45 is a sub n, my 19 has to be that n value. So what I'm going to do is substitute those 3 things in to my equation and be able to solve for a sub 0. So when I do that, my a sub n, the actual term, is negative 45. My common difference was negative 3. It was the 19th term, so that's my n value, equals, a sub 0. So from here, you're just solving for a sub 0. So we are going to go ahead and multiply by negative 3. So negative 45 equals, what is that? Negative 27 plus 30, so negative 57 plus a sub 0. So then I'm going to add 57 on both sides. Those cancel out. So we've got, what is that? 12 equals a sub 0. So if a sub 0 is 12 and your common difference was negative 3, a sub n equals negative 3n plus 12. And that's your equation. Now, if you wanted to check to make sure you did it correctly, you should be able to, again, work backwards. So if you're looking for the 19th term, a sub n equals negative 3 times 19 plus 12. which if we do that, again, 3 times 19, 3 times 10 is 30, 3 times 9 is 27, so 30 plus 27 is 57. Negative 57 plus 12 gives me negative 45. So we're good. That is the correct equation. All right, last box, box 4. Now, box 4 is now jumping to series. Those first 3 things were all about the sequences. If we are dealing with something, if we're dealing with a series that is arithmetic, and specifically it has to be a finite arithmetic series, we have a shortcut on how we can find the sum of that series. We don't have to necessarily plug in 1 through 20 for our series, find each individual term, and then, add them all together to find the sum of the series. We have this nice shortcut, because if you think about an arithmetic sequence, the very first thing we wrote on our notes today was that it is a constant addition or subtraction, meaning there's a constant growth between each of the terms. There's an equal number of spaces between our terms of that sequence. And because of that, if we figure out what the average value is for each of those terms, we can just multiply it by how many terms there are to find the sum of that sequence, of that series, excuse me. So that's basically what our formula is doing here. So S sub n, this is the sum of n terms. So our sum of in the case of number 5 that we're going to do for the example here, we're trying to find the sum of the first 20 terms of this sequence. N is, again, your upper limit, like in the formulas we saw in 8.1 day 2. A sub 1 is the first term. A sub n is the last term. And that's all based on your upper limit. Your lower limit's always going to be starting at positive 1. So our upper limit, a sub n, is going to be that last term. So in the one that we're going to be doing here, we have to find the first term of this series and the 20th term of this series to find the sum of the 20th terms, of the 20 terms. Again, the only time we can do this is if we recognize that my index is arithmetic. So 3i plus 7 is an arithmetic sequence. So that series then can be found using this particular formula. So to find our first term, which I'm going to switch colors here, to find our first term, we need to find a sub 1. We're going to plug in 1 for my I, so we get 10. Then we have to find the 20th term, that's the last term, 3 times 20 plus 7. So 3 times 20 is 60, plus 7 is 67. So there's our last term. So now we can go ahead and jump into the formula. So we know we're trying to find the sum of the first 20 terms, and that's equal to 20, since that's my n, times 10 plus 67 all over 2, and that's my formula. So again, we're averaging my number of terms, like we're finding the average value of my terms, and then just multiplying by how many terms there are. So first term plus last term is 77 over 2. Instead of dealing with fractions, I can just kind of reduce here. Right, instead of doing 77 over 2 and dealing with a fraction or a decimal, 20 and 2 can just reduce. So 10 times 77 means the sum of the first 20 terms of that series, I don't like those sevens, would have to add up to 770. And that's my sum of the first 20 terms of that series. So that formula is definitely something you want to have handy and available to you. After we go through a couple more of these, 8.3 tomorrow, we'll add some more formulas, some more shortcuts to our list. We already have those 3 from 8.1 day 2. And we have this one that we're adding to it as well. This is the sum of a finite arithmetic series. We'll have a couple of more. We'll look at the sum of a finite geometric series, and then we also have one that is the sum of a particular infinite geometric series, which both of those things we'll be looking at tomorrow in 8.3. All right. Homework is up there on the screen. It is at the bottom of your notes page. It is 422 and 423, 4 through 28, and 48 to 54 evens. As always, if you have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.